Number 6 here, this is another special rule, x to the negative 1. If you use the regular rule where you add 1 to the exponent and then multiply by the reciprocal, you end up multiplying by 1 over 0, which is undefined. So the rule for this one, the 4 is a coefficient, pull that out in front. The antiderivative of x to the negative 1 is natural log of the absolute value of x. Then you add in your arbitrary constant. That's it. All right, this next one, there's more than one term, so you just integrate each term. This first term, 9x squared, add 1 to the exponent, it would be x cubed. Then you multiply the 9 by the reciprocal of 3, which is 1/3. For the next one, the next term, 2x to the negative 1, x to the negative 1, once again, integrates into a natural log of the absolute value of x. This third term is another special rule, e to a linear function. 3x is a linear function because x has an exponent of 1. If you were to graph a linear function, you get a line. A 3x graphed would have a y-intercept of 0, slope of 3, so it's linear. So to integrate e to a linear function, if there is a coefficient, such as a 6, you bring it down. You take the reciprocal of the coefficient of x. So the reciprocal of 3 is 1/3. And then the e to the 3x, that stays the same. It does not change. And we throw in our arbitrary constant. Simplifying this, 9 times a third, you get 3. Second term doesn't change. Third term, 6 times a third is 2. So here we go. That's what we get for number 7. Number 8, 3 terms. Integrate each term separately. So 1 over x squared, I'm going to rewrite it as x to the negative 2. Same thing. 1 over x, I'm going to leave it that way. You could write it as x to the negative 1. And then e to the negative x, I'm going to leave that way as well. This first term, just the simple power rule, we add 1 to the exponent. So that would be x to the negative 1. And then multiply by the reciprocal of negative 1, which would be negative 1 over 1, which is negative 1. This next term, 1 over x, is like x to the negative 1. Its antiderivative is a natural log of the absolute value of x. This last term, it's e to a linear function once again. You take the reciprocal of the coefficient of x. The coefficient of x is negative 1. Its reciprocal, also negative 1. And then the e to the negative x stays the same, plus your arbitrary constant. This all simplifies to negative x, simplifies to negative 1 over x, plus natural log of the absolute value of x, minus e to the negative x plus c. Number 9 here, I would rewrite this. So we're integrating from 1 to 9. And we have the integral of x minus x to the negative 1/2. The negative comes from reciprocating the fraction, and then the 1/2 comes from the fact that it was the square root. This is called a definite integral. It's a definite integral because we have an upper and lower limit, the 1 and the 9. So you integrate like you normally would. The antiderivative of x would be 1/2 x squared. For the next term, add 1 to the exponent, so it would be x to the 1/2, which is the square root of x. Then you multiply by its reciprocal. Reciprocal of 1/2 is 2. This is being evaluated from 1 to 9. So we're going to replace the x's with a 9. And subtract from that, replacing the x's with the 1. Nine squared is 81. Square root of 9 is 3. 1 squared is 1. Square root of 1 is 1. This is going to give us 81 halves minus 6 minus 1 half plus 2. It's plus because you got to distribute this subtract to each of these terms in the parentheses. So this further simplifies 81 over 2 minus 1 over 2 would be 80 over 2. When you subtract fractions, you subtract the numerators. The denominator is the same. A minus 6 and a plus 2 is a minus 4. This gives us 40 minus 4, which is 36. Number 10 here, I don't like the way this is written. It may cause confusion for you, so I'm going to rewrite it. So instead of dx over x, I'm going to write it as 1 over x dx. The same thing, looks differently. How do you integrate 1 over x? Well, that's one of the special rules. It's natural log of the absolute value of x. And then we're going to integrate this from 1 to e to the 4th. Which means we're going to take e to the 4th, put it in for natural log, put it in for the x, then subtract from that, putting in the 1 in for the x. E to the 4th. E is a number. It's 2 point something. 2 point something to the 4th is going to be positive. So we don't need the absolute value bars. We can just say natural log of e to the 4th. Natural log of the absolute value of 1 is the same as natural log of 1, which is 0. Here's why it's 0. Natural log of 1 is like saying log base e of 1 equals something. Let's say that's an x, which essentially is saying x e to the x equals 1. E to what exponent is 1? Well, that's 0. You don't need to show this work. I'm just reminding you of why this exists. So it would be natural log of e to the 4th minus 0. You could also write it as 4. Actually, there's more simplifying. Forgive me. You can put the 4 out in front. That's one of the logarithm rules. If your argument, e to the 4th is the argument. If that has an exponent, the 4 is the exponent, you can move it out to the front. So natural log of e is 1. Essentially it's saying e to what exponent is z? Obviously that's 1. 4 times 1 gives us 4. So this whole thing simplifies to 4.